Alright, chemistry students, we're working our way through chapter 10, and we're talking today about the empirical and molecular formulas given if you're given all of the percentages of each of the elements in a compound, can you determine the empirical and molecular formulas? But before we get started with that, we should define what empirical and molecular formulas are. A formula that gives the simplest whole number ratio of atoms of the elements is called the empirical formula. So, for example, peroxide, which you put on soda sometimes, and the catalase will break it down into oxygen and water for you, is H2O, is H2O2. Well, that's the molecular formula. That's the actual number of elements. The empirical formula, on the other hand, is just HO. You divide both by 2, and you'll get the smallest number ratio, which would be HO, and this would be the empirical formula. Right. So this is the empirical formula for this molecular formula, and we're talking peroxide. Oh, you could do this for any random element. How about dinitrogen tetraoxide? Now, dinitrogen tetraoxide, that's the molecular formula. So the empirical formula, just divide by 2. 2 goes into 2 once, so it's 1 nitrogen. 2 goes into 4 twice, so it's going to be 2 oxygens. So it would be NO2 is the empirical formula. All right? Now, the one thing you have to remember about empirical formula is that it just shows the ratios only. It shows the smallest number ratio only. Okay, that's what empirical formulas do. They just show the ratio only. Now, molecular formula, the formula that gives the actual number of atoms of each element in a molecular compound, is called the molecular formula. And so here are our molecular formulas. But wanted to make sure we understood the distinction between empirical and molecular formulas before we move forward. Okay, so let's try a problem and see what happens here. Ribose is a sugar in RNA. RNA is ribonucleic acid. It's a nucleotide that you learned about in biology. It helps assemble proteins. It has a molecular mass of 150 grams per mole and a chemical composition of 40% carbon, 6.67% hydrogen, and 63.3% oxygen. Find both the molecular and empirical formulas for ribose. Well, in order to do that, we're going to need to determine the percent composition. The total mass of the element percent divided by the molecular mass times 100, and that'll give us our percent composition. So what we're going to do first, here, let's break this down into steps. Step 1, we're going to convert percent to grams. All right? So let's do that first. If we have our total is 150 grams, that's our total. That's how much. That's the total formula unit multiplied by its percent. Well, you can't multiply by a percent, but you can multiply by its decimal. And its decimal, you just move the decimal. You just move it 2 places to the left, and that's its decimal equivalent. So multiplied by 0.4 equals 60 grams carbon. So there's 60 grams of carbon. If 40% of 150 is carbon, then there's 60 grams of it. So 60 times 40% is, if you have 40% of 150 is 60, and that's the amount of carbon. So and we could do the same thing for hydrogen. 150 is our total times the percent equivalent, which is 0.0, the decimal equivalent, excuse me, 667, and that's going to be 10 grams of hydrogen. And then we could do the same thing with this little dot here means multiplied by, alright? That's why I'm putting that dot here. I'm not trying to confuse anybody, but that little dot means multiplied by. And I'm multiplying these two in order to get 80 grams of oxygen. Alright, so now that we have our grams, what we could do next in our second step, step 2, let's convert to moles. Alright, so now that we have our grams, we'll convert to moles. So 60 grams, 1 mole is, and we know from our periodic table that the formula unit to the molar mass of carbon is 12, and so that gives us 5 moles of carbon. We do the same thing for hydrogen, and we get 10 moles of hydrogen, and then we do the same thing with the oxygen. 1 mole, 16 grams, and you know where the 16 comes from. It's the mass on the periodic table of oxygen, because that's what we're working on now, and that would be 5 moles of oxygen. So if we look at these three together, the empirical formula is CH2O, because that's the smallest whole number ratio. Divide by 5, that'll give us a 1. Divide by 5, that'll give us a 2. Divide by 5, that'll give us a 1. So that's our empirical formula. Now our molecular formula is going to be C5, I just got that from here, C5H10O5. So that's the molecular formulas. We have empirical and we have molecular. Okay? Let's see if we can try one. We have time for one more quick one. Eugenol is an oil, and it has a molar mass. So this is our total molar mass. We have a molar mass of 164.2 grams per mole, and is 73% carbon, 7% hydrogen, and the remainder is oxygen. So find both the molecular and the empirical formula for eugenol. Well, if we did exactly the same way we did before with our first step, if you recall, is to find the grams. So let's do step 1, find the grams. 164.2 grams times 0.7314, and that's going to equal 120 grams of carbon. Alright, so all I did was I just moved this decimal 2 places to the left, and then I multiplied it by the total in order to find out how much of this is carbon. That's all I did there. And then we'll do the same thing for hydrogen. 164.2 grams times the 0.0737. I just moved it 2 places to the left. That's all I did. Alright, because this is a percentage, I need the decimal. I can't multiply by the percentage, it's way too confusing. Grams hydrogen, and then now what we have, the remainder is going to be oxygen, isn't it? Because if we add all this up, this is going to be 164 grams. That's our total. Alright, so in order to figure out the oxygen, all we have to do is subtract. So if we said 120 plus 12.1, and we subtract that from 164, then 32, is our oxygen, because it said the remainder is oxygen. So all I did was I just added these together, subtracted it from that, and I got the oxygen. All right. So let's try now to turn it into moles. And so if we say we take the 120 grams of carbon and say 1 mole is 12 grams, and that gives us 10 moles of carbon. And 12 grams, I just took this 12 grams of hydrogen. I'm trying to find out how many moles that is, see? And 1 mole is 1 gram, and that gives us 12 moles of hydrogen. And then 32, I'm just taking this 32 grams, and we know from the periodic table that hydrogen has a molecular weight of 16 grams, and 1 mole. I sometimes put an M there and sometimes I don't. Hopefully that doesn't confuse you. I'm just referring to grams there, right? And that gives us 2 moles of oxygen. So what do we have? We have a empirical. There's no E in empirical, sorry. EMPIRICAL. Empirical formula, which 2 goes into 2 once, 2 goes into hydrogen 6 times, and 2 goes into carbon 5 times. So it would be C5H6O. And then the molecular formula would be C10H12 and O2. All right.